Hello, my name is Levon Habosian. I'm the Field Application Engineer here at Trimec. Solidworks PCB, something new for electrical engineers. We're all used to SolidWorks with mechanical engineering, but now today SolidWorks has introduced a PCB tool. What you're looking at on the screen is all 4 editors of SolidWorks PCB, all built into one. It's a unified design platform. Now, the unified data model is something that is unique to the PCB world. So now I'm going to show you the cross-probing capability right here, a nice example of cross-probing between the editors. So let me merge all these together, and now you can see these little tabs on the top. One of the differences we have with our tool is we can have a projects panel that has all the list of all the projects in it. You have the different tabs where you can see the ribbon technology. You can also add new tabs or panels on the fly as you need them. So here's a shortcuts panel that I'm going to just attach to the side of my environment. And when I need it, I can just have it come out, or I can pin it and have it pinned so I always have access to it. So you can set up the environment to be more comfortable to the way you want to work in your own environment. And you can save that off to bring it in anywhere on any machine at any time. So there's also system preferences that we can use. Again, more comfort for you. What do I want my mouse to be able to do? What do I want in my schematics? Do I want display crossovers or cross junctions, break wires? Do I want to give it some default grounds or other default information for templates or things like that? Again, interactive routing. What kind of routing do you want to do? Do you want to restrict yourself? Do you want to go ahead and be able to do everything the tool can do for you? You can set up favorites. If you need favorites that vias that you're going to use all the time, set them up ahead of time. Speed gets you to finish your designs faster. So now we have some schematic capture tool. Let's go over that for a little bit. On the top there is our ribbon technology. Makes it simple to be able to find the functionality that you need to draw your schematic. We tried to pull everything to the top so you don't have to go down and drilling down different boxes. You do have the capability of right mouse clicking and getting access that way if that's the way you like to work. Or we also have, I showed you the shortcut keys where if you want to be a keystroke expert, you can do that too. So now let's zoom in a little bit and do some schematic stuff here. So let's say you want to work on this bus and you haven't quite done anything yet. You can go ahead and grab it and move it, just like you would expect in a schematic capture tool. You can grab some bus entry points and hit the space bar and go ahead and just add all those type functions. Now bring it over. Attach it to the pins, bring it back, and there's your lines all hooked up for you. Ease of use is what we're looking for here. Simple to use. Add a label. I just grabbed it from the top. All the labels are embedded in the unified data model, and I'm going to grab them and place them. This is a bus, it knows that, it increments the labels for us. So again, ease of use. Adding a wire, very simple, click wire. Just go ahead and draw it across. Again, ease of use is what we're all about. So let's zoom out a little bit, show you some other functionality that's built into the tool. On the ribbon, we have other functions that are preloaded. So you need a ground symbol. You can just grab it and place it down real quick. You don't have to worry about creating these things in your library. It's already there. You got a library panel on the side. If you're looking for different libraries, different parts, you can choose which library you want to go to. Look at the part. You can see them displayed. Grab it, pull it over. Real simple to add parts from a library. So again, ease of use is what we're all about here. Functionality that makes us different. What I just did was I clicked on the symbol and came up and shows me the parameters that are in the symbol. I can add parameters that are internal to my company, an internal part number, an internal spec. And you can see I just added PD num and the value is 123. That's my internal part number. And now what I can do is go ahead and show you supplier links. Supplier links is something definitely makes us different from the rest. We can go out and search suppliers that we're working with. Give it a keyword, do a search, and it'll pop up DigiKey, Farnell, Newark, all the different suppliers we're working with. You can select the part, and in that part you're going to see all the parametric data that comes with that part, that are supplier information. You have downloads you can for documents, you have pricing information in quantities, availability. All that information is there for the engineer to be able to do his job. So let's say you like the part that you're looking at, and what you can do is say, okay, this is the part I'm going to use on my design. Go ahead and add it, go back. Now again, open up that symbol and see what you get. Now you have the supplier information in there, the supplier part number, and when you generate your BOM, all the other parametric data that you just saw has been located in the unified data model. So you have the ability to create reports with your BOMs when the time comes. All right, let's talk a little bit about PCB. Okay. So again, you have the ribbon technology. All the functionality you need to do your PCB is right across this top. And this is a theme, I guess, ease of use. I don't want to drill down into multiple stages to find what I'm doing. We have a layer stack manager. We have presets that are set. So you want a 6-layer board, as a starting point. You can go ahead and choose that, and now you have a 6-layer board to start with. You can edit the thicknesses, dielectrics, and all the information you need. You can add layers. I just picked a 6-layer board here for this particular demo. So, what do we have? Again, design rules. You need to constrain your boards. You have the ability to do electrical constraints, clearance rules, routing constraints, component clearances. You can set up the differences between how far away each component's going to be from each other. It'll highlight it as you're doing your placement. You want to set up some classes. You can go ahead and set up classes with this tool. And let me show you the class button. Open up the classes. Net classes, component classes, layer classes, all kinds of functionality here that you would need. So now I have a template PCB board that I'm going to be using. It's just a square. It's a default that we have set up here at Trimec, and it's what I like to use as a starting point when I do when I create a project. So let's go over and talk about the collaboration. So in this panel we have Solidworks connector. This is state-of-the-art MCAD, ECAD integration we're going to be talking about right now. So built into Solidworks PCB is this connector functionality. It allows me to transfer data to the mechanical folks. But before I do that, I need to transfer data from my schematic to my PCB. And before I do that, I'm going to show you this PowerPoint just to explain what's going on in the background. Solidworks PCB Services is a repository that is only used for this purpose. It does not connect to your PLM or PDM or ERP systems. Its strict purpose for this repository for the collaboration between MCAD and ECAD. As you can see on this PowerPoint, you have the services set up. You have Solidworks PCB on one side, Solidworks Mechanical on the other side. You can still use your SVN repository if you choose to inside a Solidworks PCB. You can still use your PDM system in Solidworks if you choose to. You don't need to part from your environment. It also has a web interface that you can assign a contractor or somebody like that to come in and do the collaboration with you with a username and password that you would set up. Okay, so let's get both tools together and let me show you how this all works. So the first thing I need to do is obviously understand what the shape of that board's going to be. So let's go ahead and talk about Solidworks Mechanical. In the Solidworks Mechanical side, there's also the PCB add-in. You'll enable that through your add-ins functionality. It is in Solidworks 2016 and above. So if you have those versions, then you already have the add-in. New board assemblies. If you want to start a project in Solidworks Mechanical, you can. Or you can start it on the Solidworks PCB side. Doesn't matter where a new project is created. If you're going to do this in SolidWorks Mechanical, you would go ahead and click the new board. The repository would show up. You can see a list of different projects I have in there, and go ahead and say create new, and then it's going to, name, description, and now you can go ahead and it would just add another project into that repository we talked about. But I'm an electrical engineer. I started my project on the electrical side. So let's go over to the electrical side. So the first thing I want to do is figure out what the shape of that board is going to be. So I'm going to push that over to the mechanical side just by hitting the push button. And maybe call it Rev 1 and give the mechanical engineer a note saying, please shape the PCB. And post that into the repository. I get a date stamp and a time, and the information is now in that repository. So he's going to go and say pull the board from the project, and we're working on this guy. Say OK, and that's going to go ahead and look out there and say, hey, is there already something that a mechanical guy has started? It's going to want to save a SolidWorks assembly, so you would go ahead and save that into wherever your location may be. Then it's going to look in the repository and say, is there any data I need to pull? It's going to see that I have a template board in there. It's going to see my note. And now the mechanical engineer has the board, same shape as mine, and we are now in sync. No DXF file, no IDF file, no step file outputs are needed. The tool just works. Now, from the mechanical point of view, many different ways to shape a PCB. I'm going to sketch this out and just change some shapes, maybe chamfer some corners or something. Let's say I do that. I'm going to go ahead and maybe move that down and decide, hey, maybe that's where I want to be. And I'm going to go ahead and push this back to the electrical engineer. And give him a note. Done. Just a note back to the electrical guy. You can write a whole story there if you'd like. Now, from the electrical point of view, you notice new changes have been detected pops up. There's my note in a date stamp, and I'm going to go ahead and view those changes. Looks like there's a couple of new objects that have been changed or added. If you like what you see, you accept it, and there you go. We have the exact same PCB on both sides of the tool. Again, a nice, easy transfer. All right, next steps. I need parts on my PCB so I can do placement. So let's add those parts. And the way we add those parts is by running an ECO. We're going to import the changes from the schematic into the PCB. All the data has already been compiled and is in the unified data model. We just need to bring it in. So we can validate the changes to make sure that all the parts have footprints, everything's all matched up. We can generate reports of the changes. We can only show errors if that's what we want to do. I'm going to go ahead and just execute this. You can notice all the check marks, everything went green, so we're all set, ready to go. I got some parts here. Let's move them over onto our PCB for now. Okay, let's go back to the two tools. Now, I'm going to go into 3D mode here real quick and show you, here's all the 3D models. Now, what I need to do is transfer these models over to the mechanical side. All these models are embedded inside the SolidWorks PCB library. I have a 2D footprint, and I've embedded the 3D models onto those footprints. Step file, a Parasolid, a SolidWorks PRT file. I can bring those in and embed them in my library, and they're always going to be there to use down the road. So let's push that data over to the mechanical engineer and say, please place connectors, cons. I don't know where they go. and let's post that. What's it doing here? It's taking those models and creating a pair of solids with the repository that are ready for now the mechanical engineer to pull. Now that we're in sync together in the repository, the tool knows that there's some changes. So it's asking me to place some connectors. So let me view those changes. And here's a list of all the parts that are coming in. Now I can choose to accept just that part and not the rest, or I can go ahead and check them all and accept everything. And if I check everything, it's going to go out in the repository, see what's out there, and bring in all the parts and place them in the exact same XY location that I have on my PCB side. And you can see right here, again, we have our 3D views in both tools. So a nice, easy, simple transfer of data. No IDF, no step, no EMN. So let's do the next thing. In the mechanical tool, under settings, I also have the ability to fix these components as they came in. I chose to keep them floating because I know I'm going to move some around, but if I clicked fix, you would actually have to go to each individual part and float it to move it. So let's go ahead and move some parts around. Let's just say that's what we're going to do today. I'm just going to push this back and say done. Post. Now, come over on the electrical side. Changes have been detected. Let's view those changes. Now, a couple things we can do. I can look at each part one by one and see where that part's going to go. Or I can go ahead and take a look at the entire design and see if I like what I see and where everything's going to go. I can go into the 2D mode and do the same thing. One by one. If I like what I see, I'm going to check them all and say accept, and now it'll automatically place those where I need them. And once it's done, I will expand this so you guys can see it. So there's the new placement that I just sent back. So a nice easy transfer of data back and forth between electrical engineering and mechanical engineering. All right, let's talk a little bit more about the Solidworks PCB tool. And in order to do that, I'm going to open up another design. Okay. So here's a design that's, we've gone through our placement, we've agreed on it with the mechanical engineers, and now it's time to do some routing and some other work with this design. Okay, routing. Let's talk a little bit about routing. So, interactive router, differential pair router, and a multi-router. Interactive router, pretty simple, pick a pin, start drawing your nets. Multi-route, let's say I have a bus and I want to multi-route these four pins. I'll select them, hit multi-route, grab it, and now I can go ahead and route all the different nets at the same time. Again, hit control and it'll automatically route. Easy to edit, just grab and start moving things around. So nice easy way to do multi-routing. We also have the diff pair router. I have a couple of diff pairs set up right here, and go ahead and add diff pairs, grab it, pull them out. Again, I have a width rule set up, so I hit the number 3, and now I can start doing my diff pair routing. Let's say I want to neck it down a little bit. I can go ahead and neck it down and continue my route. Okay, so that's cool. We got that all set up. But you know what? I think I did some routing earlier on this design that I just want to go back and check. So we have a tool called version control. On the project panel, you notice that I have these little green check marks. That means that all these documents are in version control. But I've been changing this around. And if I highlight this little folder right here, it's going to tell me, hey, this is open and modified. So, but I have something in version control already. So using the storage manager, I'm going to pop that open, and I have the PCB board here. I have this modified open document that I've been working with. I have some other revisions over here that I want to look at and do a compare and see what the difference is between what I just did and what I had done earlier. Maybe I was on vacation when I did it. So what that's going to do is it's going to open up the design side by side. Here's revision 24 and here's my current one. This differences box is going to open up, and I'm going to be able to go ahead and click on that. It's going to highlight that diff pair I was just doing, and then it's going to also go and highlight the one I did previously. Now you notice the shapes are different here versus here. A nice visual of differences, not some ASCII file that you have to go in there and parse through. Imagine using version control when you're doing the MCAD, ECAD interface with this tool. You'll have points in time when you send something to mechanical and when you got something back, and do a visual compare that way. So while we're in PCB, we're done. Let's say we're happy where we are, the routes are all finished, we think the board's done. We have to generate outputs. So we have the ability to generate the typical outputs that you would expect. The Gerbers, ODB++, we have IPC 2581 capabilities, pick and place assembly drawings, but I don't want to do those all one by one. We have the ability to come into our projects tab and say generate outputs. And what that'll open up is this box, and allows me to configure all the different types of outputs that I want. I can come in here and select what I want to do, save it, say okay, and then check this box off, and that'll tell me, okay, anything checked off here, hit generate, and that'll automatically generate all those files for me. I'll go get a cup of coffee, come back, and all the documents will be created for me. In the Projects tab, you'll have a different area here, generated outputs, so documents. So you can see I have a list of different types of documents that I've asked to create. I have more documents down here, the different Gerbers in this case. So all that will be saved in your project space, and then you can check them in to version control with the tools. Okay, so that's the end of the webinar. And if you have any other questions that haven't been answered with this webinar, then please get a hold of us at Trimec, and your sales rep is available to discuss SolidWorks PCB with you. I hope you enjoyed the webinar, and thank you very much, and we'll hopefully be speaking with you soon.